name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject Microcontroller and Embedded Systems Design having code KC061, what we have covered, we have completed our first 3 units, unit 1st, 2nd and 3rd, and a few lectures back we have started with the unit number 4th. And we have seen that unit number 4 is all about the Internet of Things. So, in the previous lectures we have completed most of the portion of IoT, that is IoT architecture, IoT characteristics, applications, and what is the typical infrastructure of IoT, IoT wireless technology, and WSN in previous lectures. So, in today lecture we are talking about the hardware platform for IoT, under which we will study the sensors and the role of input output. So, these are the topics we will cover. So, I am taking the slides, just a second. So, today we will cover these topics. So, under sensors for IoT, we will explain the principles of sensor, what should be the principles of sensors. After that, we will discuss the role of input output devices that is used in our IoT based system. After that, we will discuss about the transducer, what is transducer, and we will differentiate between the sensor and a transducer, because most of the students are confusing about the difference between the sensor and transducer. They are in a definition they are common. Okay. Sensor characteristics we will study. After that, we will discuss what the various types of sensors that can be used in our IoT based system. Types of transducer we will see. After that, I will through pictorial representation, through visualization, I will discuss the various types of sensor, important sensors that can be deployed in IoT based system. After that, we will discuss the role of input output, the input output. These are the topics we will cover in this lecture. Let us start one by one. Just a second. So, first topic is sensors for IoT, under which we will study the principle of sensors and the role of input output. So, first one is the principle of sensor. Before going to the principle of sensor, we will discuss what is sensor. Sensor means, as the name implies, to sense something. So, sensors will convert physical parameters from the environment. Like from the environment, you can take heat, light, sound, etc., pressure, humidity, and the sensor measures the physical quantity and convert these physical quantity into the electrical signal and voltage. Why they are converting into the electrical signal and voltage and current? Because our computer is capable to deal with the electrical voltage with digital signals, and through sensors we need to convert that physical parameters into the electrical voltage or current, so that it can be further can be accessible by our data acquisition unit. So, it gives accurate reading after calibration. We need to calibrate the signal, so that accurate signals readings can be done. So, here this is a sensor. Sensor converts the physical changes in the environment into the electrical output voltage. Here it is electrical output voltage, that is continuous in nature. It may be like this, electrical voltage or current with respect to time. Okay. So, here you can see the more explanation of the sensor. Sensor has a sensing element, conditioning. Okay. So, it converts physical medium from the environment, physical parameters. For example, I am taking temperature, and it converts the temperature physical parameters into the information, and this information we are talking about the output signal, that is in the term of electrical voltage and current. Okay. So, sensor will convert the physical parameters into the electrical voltage or current. So, sensor is a device that produces an output signal for the purpose of sensing of a physical phenomena. As the name implies, sensor produces an output signal in the form of voltage or current in response to a physical phenomena. They are sensing the physical phenomena. Physical phenomena means the parameters which are present in the atmosphere. So, this signal must be produced by some type of energy, such as the physical parameters we are talking about: heat, light, motion, humidity, chemical reaction, pressure, etc. So, once a sensor detects one or more of these signals and input, they can detect this is sensor, this is input, and this is output. So, once sensor detects one of these signals as an input, it converts into a analog or digital representation of the input signals. So, the signal can be in analog in nature, output signal we are talking about, and it may be in the digital form output. Okay. So, based on this explanation, we can see that sensors are used in all aspects of life, because in daily life we are talking about the various types of applications. So, in each and every application we need sensors for data acquisition to gather the data from the environment. Okay. So, it is used in our all aspect of life to detect and or measure different conditions. So, typically sensors we can say that it convert a recognized signal into an electrical analog or digital output that is readable. Okay. So, this is the basic introduction of sensors. So, we will see the more about a sensor. Sensor, for example, thermometer. Thermometer is a sensor. What will thermometer will do? It is a device that detects or measures a signal or stimulus. Basically, a thermometer is a device that detects or measures a signal or stimulus. Thermometer, what will thermometer will do? It measures the input and will give us a about the temperature, present temperature of the environment. So, it acquires information from the real world. Okay. So, another term is actuator. We can say that both use same concept. Sensor convert one parameter into another, and actuator will also do same, but actuator do some type of reverse operation of a sensor. Actuator basically convert the electrical voltage and current into the mechanical movement. For example, our fan, if fan is a actuator, but in for fan you can see that we are supplying the power supply electrical voltage, and through this electrical voltage fan will rotate, it do mechanical motion. So, fan is a actuator. Okay. For example, heater we can also date that you are supplying the power supply, and we are using through power supply it will generate heater. Okay. Heater is also actuator. So, basically in actuator we can see that it converts electrical voltage and current as an input to the output, and output will may be a physical parameters, okay, like heat, mechanical motion, pressure, etc. Okay. Some displacement like LVDT. LVDT is also a, we can say, the actuator. You are providing the power supply, your system will move. There is a displacement of the devices. Okay. So, we can say that actuator is a device that generates a signal or stimulus. So, here you can say that sensors take the data from the real world. From the real world, the data here may be a humidity, here heat, here pressure, etc. Various types of chemical reactions in the environment, and they take data from the real world and convert into a intelligent feedback system, convert into a electrical voltage and current. Okay. Like this, continuous in nature or it may be discrete in nature. Okay. And actuator will do reverse operation. They take electrical voltage as an input, voltage and current as an input, and convert into the real world data like heat, displacement, pressure, etc. Okay, mechanical movement. So, there is a, in this figure there is, you can say that there is a feedback to the system from this one to the another this one. We can, this is, there is a, you can here you can visualize the, there is a feedback in the system. So, typically interested in, we are talking about the electronic sensors. So, electronic sensor convert desired parameter into a electrically measurable signal. So, general electronic sensor we can see in previous slide that they are it uses two concept, that is a primary transducer and a secondary transducer. In our further slides we will see about the transducers. So, transducer convert one form of energy into another form of energy. So, sensor uses the same concept, they convert the real world data into the electrical voltage or current, but here we can deploy the two things, primary transducer, secondary. Primary transducer changes real world parameter into electrical signal as a normal operation the sensor will do, but again secondary transducer convert this electrical signal into a digital analog or voltage values. For example, here if we are detecting the heat, our sensor detecting the heat, through primary transducer it convert into the electrical voltage or current, and again through electrical voltage or current, secondary transducer will convert into the usable values that can be readable by the system, that will be readable by the computer system, because computer system only read the digital values. So, typical electronic system has a sensor which can detect the input signal, measure and convert it into the analog or digital signal sensory, and again the data we are collected from the environment through the sensor, okay, it converted into the microcontroller, because this type of data that we are collecting from the gather from the sensor, it need for further processing. We need to process this data. For that we need some control unit, and control unit is like a microcontroller. We need some signal processing, digital signal processing, because the data we gather from the environment, it may have some noise, it needs some amplification, some filter, wave shaping. So, all will be done in the signal processing unit. And we have a communication unit. Why we are using communication unit? Because the data gathered from the sensors are further can be further provided to the user, and how it can be provided? It will be provided through some communication unit, wireless communication unit. Here we are talking about a wireless communication unit, that may be a Bluetooth, that may be RFID, gateways, etc. Okay. So, this data that is gathered from the environment, and after processing, for example, here data is in the raw, it need some amplification. So, this is maybe a distorted data. After signal processing, this is basically a noise may be removed, it will amplified, and this perfect signal will further go to the computer database, and it can be further processed, mining can be happen, and we can process that data at the user net. Okay. So, we will talking about the transducers. Basically, a transducer is a device that convert a primary form of energy into a corresponding signal with a different form of energy. So, transducer basically convert the one form of energy into the another, but sensor convert one form of energy into the same another, but it only changes the signals. Okay. So, primary energy forms are, we can see the mechanical, thermal, electromagnetic, optical, chemical, etc. It take form of a sensor or an actuator. So, basically sensor is a part of a transducer. Transducer convert one form of energy. In sensor, actuator is both a part of a transducer. Okay. Transducer convert one form of energy into another, but sensor, actuator convert one form of energy into a same form of energy. Okay. So, for example, sensor is a thermometer. We have seen in a previous slide that thermometer convert the real world data, and it convert into the measurable values. Okay. Here you can see that there is a basic transducer. In basic transducer, we have both the unit sensor. Sensor is a part of our transducer, plus signal conditioning. Signal conditioning is done in the basic transducer unit, and measuring quantity, it may be a heat, pressure, temperature, etc. And we are converting this into the meaningful information, that is a perfect signal. It may be analog, it may be digital. Okay. And before meaningful get the meaningful information, the signal, the data collected by the sensor, it need further signal conditioning, signal conditioning. Actuator, we can say that the heater, we have seen in the previous slide that heater is a actuator. You are supplying the power supply to the heater, and it will generate the heat. That is a reverse operation of the sensor. So, here you can see the big picture. This is the feedback system. Okay. We are connecting the data from the real world, sensor converted into the output, and again output is a electrical voltage or current. If we actuator use electrical voltage or current to convert into the real world. So, here we can see that primary transducer, we have seen in a previous lecture, that the secondary transducer, real world data convert into the analog signal through the primary transducer. It will done by sensor, and sensor through sensor, secondary transducer, we convert this signal into the usable values. As you have seen that input signal converted into the sensor data, it may be analog, digital, and again microcontroller, signal processor, communication unit, we are converting into the meaningful information, that is accurate information that need to be accessed by the user. So, now the question arises, what is the difference between the sensor and the transducer? As previously we said that sensor is a part of a transducer. So, the words sensor and the transducer are often used interchangeably. They are often used interchangeably. That means that some say that sensor is same as the transducer is same as the sensor, because both are used to convert one signal to the another. Okay. So, what should be the difference? But they have some different characteristics. Sensors and transducer are both devices which react to change in a physical quality in their surrounding. One common is thing that both devices react to a change in a physical quality in their surroundings. For example, in our environment, we have a various physical quantities, like we have a heat, pressure, moisture, humidity, etc. So, both detect that and convert it into a meaningful information. So, the main difference between a sensor and transducer is that sensor senses the difference or change in the environmental they are exposed to and gives an output in the same format. Notice this point, same format. They are sensor basically collect a physical environment parameter and convert it into a signal in the same format, but transducer takes a measurement in one form and converts it into another form. For example, a measurement which is not electrical and converts into an electrical signal. So, basically sensors convert a physical signal into the we can say the electrical voltage or current, it keeps in the same format, but transducer converts one form into another form of signal in the different format. That is the main difference between this process is called a transaction. So, at one go we can say that sensor and transducer are same, but their characteristics are different. So, sensors for IoT, under which we will see some more. For example, a thermistor. Thermistor is basically a type of sensor. It will respond to the change in the temperature, but does not convert the energy into a different format. It keeps in the same format to what it is originally sensed. So, thermistor is a sensor. It thermistor what will do? It sense the temperature, okay, and keeps in the same format. But when this thermistor is not on its own is a sensor, but when it is incorporated into a bigger circuit, if we are using the thermistor in a bigger platform, it will become an element of a transducer. For example, thermometer is a transducer, and we can say a thermistor as in its own is a sensor, but when it is incorporated into a bigger devices, it it works as a transducer like thermometer. So, these are the some points, the difference between the sensor and transducer. First point is the based on the working principle. Sensor senses a physical measurement and makes it readable for the user, but keeps in the same format. We have also discussed the sensor measure the physical environment, convert it into the electrical voltage convert, but in the same format. But transducer senses the physical environment, convert it into a one form to another. For example, non-electrical to electrical, maybe in the different format. Sensor keep in the same format, transducer convert one form energy into another, but in the different format. For example, non-electrical to electrical. For example, sensor may include motion sensor, thermistor, pressure sensor, switch, various types of sensor. Transducer have a microphone. Our microphone is basically a transducer. Microphone we are for example, I am using microphone. I am providing our voice to that, and this microphone convert my voice signal into the electrical voltage or current. Reverse operation may be done. We are getting the for example, loudspeaker. Okay, loudspeaker get the data as a voice and convert into the another signal. So, pressure transducer, linear transducer. Application uses patient monitoring, infrared toilet, flushes, liquid dispensing in drink machines, all employing sensor devices. In case of transducer, HVAC, heating, ventilation, and AC means air conditioning. Monitoring, HVAC means heating, H means heating, ventilation, V means ventilation, and AC means air conditioning, monitoring. All deploys transducer devices. Engine controls, we can use transducer, steering system, ramp and bridge lifting system, all are using the transducer devices. So, now next topic is under sensors for IoT is what should be the various characteristics of sensor. We will discuss some of the important characteristics of sensor. So, before going into the characteristics of sensor, we will see what is a good meaning the good sensor, what is the ideal sensor. So, a good sensor or ideal sensor uh, obeys the following rules. It is sensitive to the measurement property. It should be sensitive because it should be sensitive to the parameters it is taken from the environment. If it is not sensitive, how it will provide us the accurate data. Okay. It is insensitive to any other property. If we are deploying our sensors in our environment to detect a heat, so it should be sensitive to the heat, it should not be sensitive to the humidity. The type of sensor we are used, it should be sensitive to that particular application for which it is deployed. It is should be sensitive to the another parameters it is not we considering for. Okay. So, in its application. So, it does not influence the measurement property. If you are they are taking the data from the environment like heat, pressure, it should be sensitive to that, it should be sensitive to other devices, and it does not influence the measurement property. For example, if we are taking measuring the heat, so it does not affect the measurement property heat. It is converted into electrical voltage or current, but did not affect the actual original information like heat. Okay. So, these are the various characteristics of sensors. Sensors suffer from the following deviation. First one is the sensitivity error, hysteresis error, offset error, non-linearity error, quantization error, alias error, noise, drift. These are the characteristics of sensors. Sensitivity error means if it should be sensitive to the devices. If it is not sensitive, then there may be a sensitivity issues. Hysteresis error, okay. There is some be a interference in between the devices. Offset error, bias, non-linearity. If there is non-linearity, so we cannot get the actual information. There is a distorted information. Quantization error, actual information cannot be get if there is a quantization error. Alias error, two devices, two signals may overlap with each other. This is aliasing effect. Okay. Noise means there in original information there may be some noise which is added along with the environmental parameters. Drift in the signal, it is all the characteristics of a signal, and it need to be take care while designing any sensor. So, what is the types of sensor? There are classification of sensor. First one is active and passive sensor, after that analog and digital sensors. Okay. After that, we can also classify the sensor into the following criteria. First one is the primary input quantity, what quantity they are measuring, that is that also a type of a sensor. For example, temperature sensor only detect the temperature, they are not detecting the pressure. Okay. Transduction principle, to which is it based upon, using physical and chemical effect. Material and technology, what is the type of material and technology from which sensor is made up of, it is also classified to that. Property application, okay. To what particular application we are using sensor, it is also one of the criteria. Okay. So, we are taking some common types of sensors. First one is the light sensor. We have a IR sensor. I am taking some of the common. We have a photodiode sensor, LDR sensors. We have a temperature sensors, thermistors, thermocouple, like we can also use LM35. We have a pressure, force and weight sensor like strain gauge sensor, which can measure the pressure, load cells, weight sensors. If we are talking about a LVDT is basically a transducer. It is not in the category of exactly in the sensor. Okay. Biosensors, chemical sensor, we are not limited to this. We have a numerous types of various types of sensors. Okay. We are taking some common. Okay. Types of transducer, we are talking about active and passive, transduction principle, digital, analog, primary, secondary, and a forward transducer and reverse transducer. We will not go into the depth of all this. We will just take one active and passive transducer, transduction principle. Like sensors, there is a types of transducer based upon the same fact, what type of application we are using. So, I am taking some pictures from the internet. It is displaying the some common types of sensors. Here you can see there is a color sensor. Here is a temperature sensor LM35, it has 3 pins. We have a gas sensor, we have a light dependent resistor LDR, we have a thermistors temperature sensor, We have proximity sensor that can detect nearby objects. We have ultrasonic sensors that can detect motion of any up to a 10 meter. We have a soil moisture sensor which can detect moisture of a soil. We have a IR sensor. We have a PIR sensor that can detect a motion of a nearby objects up to only 2 or centimeter. They have a same principle, PIR ultrasonic, but PIR sensor only sense the nearby objects. We have a rain sensor. It can detect rain, okay, falling drops from the environment. Heartbeat sensor, it can detect a heartbeat of a person. We have a IR sensor, transmittive type. Infrared sensor, okay, this is a transmitter reflective type. We have a touch sensor. We can use touch sensor in our mobile phones. It may be capacitive or inductive. We have a humidity sensor. It can sense the humidity from the environment. We have a photo transistor. We have a gyroscope sensors. Gyroscope basically detect the motion of a person we are using in our system. We have a soil moisture sensors. These are the various types of sensors that can be employed. So, what we can say that sensors are everywhere. We can use in our homes, workplaces, shopping, hospitals. They are embedded in smartphone. In our smartphone, there are various types of sensor: gyroscope sensor, motion sensor, camera is also a sensor. So, sensors have been around for a long time. From long term, they are around for us from 1880s to late 1940s. So, IoT and its counterpart, the industrial internet of things. We are talking about the industrial internet of things. They are mostly deployed as sensors, are bringing sensors to a new level. So, what is the role of input output? The input output device works on the local device of a remote controlling host. Okay, role of input output means the input output parameters we are using. The input output IoT device is controlled by data communication with the controlling host through the input output device. The IoT system simplifies the internal communication. So, what will happen there? In IoT based system, we have a hardware we have a IoT, we have various types of sensors, and one input quantity to the another quantity. So, role of input output is that what type of input we are using and what type of output we are converting, all will be taken by the input output devices. So, thank you everyone for your patience. I hope you have enjoyed my lecture. Thank you.